So here's my problem. This is already written out for me. If I'm writing this on notebook paper, of course I would have to write that. But my solution, I am definitely not going to recopy the problem. Here's my solution down here. So I start by saying proof. I write down the more complicated side. Mathematically, you could do it either way, but it's much easier if you start with the harder side and turn it into the easier side. Put an equal sign, and then make some changes. Anything that's legitimate. Again, my best advice, it doesn't always work, but some good advice, change everybody to sines and cosines. A lot of times that helps. So tangent, he's sine over cosine. Notice that I'm always writing an angle here. I'm never just writing this. That doesn't exist. There's no such thing as sin. It's sine of an angle. See, cosecant is 1 over sine. So cosecant squared, we want 1 over sine squared, minus tangent is sine over cosine. I don't even know where this is going. I don't even know if I've ever even done this problem. Where you're going to watch me figure this problem out as we go. I'm kind of keeping in mind where I'm trying to hit. Notice, for example, that I've got 2 terms here, and in the answer I've only got 1. I'm just trying to hit cotangent, so somehow I'm going to have to add the fractions together. Okay, let's see what we can do mathematically. Well, I could cancel one of these signs. Okay, so maybe write this guy as 1 over cosine sine. And now I look and go, okay, well, if I'm going to add these fractions together, I need to have a common denominator. So the common denominator is sine times cosine. This guy's got a cosine. He needs a sine on top. So if I multiply top and bottom by sine, on top I'll get sine squared. Now I've got a common denominator. I can add the numerators together. That's 1 minus sine squared of theta. But wait a minute, remember, so this is not part of my proof. I'm writing this so you'll remember it. Sine squared plus cosine squared equals 1. So cosine squared is 1 minus sine squared. So on top, I could, if I wanted to, why not, replace that with a cosine squared. So that would equal cosine squared over cosine sine. Hey, I could cancel one of those cosines out and get cosine over sine. Wait a minute, cosine over sine, that's cotangent. That's what I was trying to get to. I didn't do it on purpose, it just happened because these 2 sides are equal. I didn't have a choice. I got cotangent of theta. I started with one side, I kept all my equal signs lined up, and I made a change. Notice I didn't write the same thing here. Across each equal sign, I made a change. Another way we could do this, if we physically had the space, is to keep going left to right. Equals, equals, equals. But we literally run out of space. That's why we go down. It's just a chain of equals. This equals that, which equals that, which equals that. It's a chain of equals, so the first and last must be equal. We've proven that those 2 things are equal. So we tell the reader the proof is over, and we're done. So your answer on these problems, the thing I'm grading is this. That's what I'm grading, the entire thing. And there are so many ways to get this wrong. If you're all over the place, it's wrong. It should look like a waterfall, nice and pretty. This is a well-written trig proof. If you work on both sides, a lot of people like to do that. They like to go start here until they meet in the middle. Sure, if you want to do that as your scrap work, go ahead. I'm not going to grade it. Do that off on your own and then write it up like this for me.